Hello. Okay, I'm doing my presentation on minimum description length recurrent neurals. I'm only doing my part right now, and so I wanted to talk about the overview, and we're doing the introduction. And what we've learned so far is artificial neural networks are impressive across wide ranges of domains like linguistic data, computer vision, and many more when dealing with large training corpora. And resources are available, but small input sequences are real challenges. Um, the problem to be fixed is the overfitting of data and producing categorical outputs and being interpretable. And solving these issues can be achieved with the MDL principle, which aims to balance complexity of the network and its accuracy. So some of the foundations and related researches that were used was the simplicity in neural networks. So in 1993, there was minimized encoding length of weight, and in 1997, there was the proposed simplicity metrics for network discovery. Most recent works have simplicity being applied in areas like linguistic modeling and program introduction induction. Minimum description length principle. This is the MDL. The MDL principle has a Bayesian inspired framework for balancing model complexity and data fit. Phonology and grammar learning was applied successfully later. A- Optimization with genetic algorithms, better known as GA. Early research used GAs to evolve feed forward and recurrent networks. The genetic algorithm enabled flexibility beyond differentiable architectures required by backpropagation. Grammar induction with RNNs, long-standing challenge addressed by RNN-based approaches, and recent efforts have explored symbolic interpretation of RNNs. So for the learner of the minimum description length, the core concept is to minimize the sum of G, which is the size of the network, and D, the G is the error in encoding data with the network. The goal is to balance generalization and data fit, thus having small general networks and avoid overfitting. Some advantages of the minimum description length is to ensure in intermediate level generalization and compact interpretability networks. Network encoding and representation. Directed graph representation has arbitrary numbers of units and weighted connections that include forward and recurrent connections. A coding scheme would have each network being represented as binary strings with components such as activation functions, outgoing connections, and weight and biases. Uh, so this is one of the diagrams or figures that were included, and what it consists, it consists of two inputs: the yellow unit one and two. Let me. Do I have a pointer? Yeah, yellow unit one and yellow unit two, and one output unit with a sigmoid activation. The network has one forward connection from 1 to 3 and one recurrent connection from 2 to 3, represented by a dashed arrow. Do you see dashed? Recurrent connections feed a unit with the value of another unit at the previous time step, and thus will allow for development of memory across the different time steps of a sequential task we are interested in. Search algorithm genetic optimization. For the genetic algorithm, it explores a vast search space of network architectures and it supports dynamic changes to architecture during learning. Key to the genetic algorithm operations is the initialization of random networks and minimal structures. The mutation that adds and remove unit connection biases and adjust weight. And selection based on the MDL score. The lower is better. This is a genetic algorithm that they were using, and the formula on how to go about using it. And the last one is the island model, which divides population into subgroup islands, and periodic migration. It prevents premature convergence. And that is my presentation. Thank you.